Hello viewers, this is Ronald taking you through today's tutorial on A-level applied mathematics, and this tutorial we are going to talk about a topic of linear motion involving two particles. So this topic is in mechanics and is suitable for students in both senior 5 and senior 6. Now these are the very questions I left in the previous video. So question 1 was that and question 2. So I believe that you try them out, and now we are going to try to see how the solutions could be worked out. So we are going to start with question 1, and question 1 says two cyclists A and B are 36 meters apart on a straight road. Cyclist B starts from rest with an acceleration of 6 meters per second, while A is in pursuit of B with velocity of 20 meters per second and acceleration of 4 meters per second squared. Then the question is that find the times when A overtakes B. So before that, we are going to first design a simulation for this question. So we shall have cyclist A and cyclist B. So cyclist A will be at point A and cyclist B will be at point B. Okay, so there's two cyclists. They told us that they are 36 meters apart, meaning that the distance from A to B is 36 meters. Then they also told us the cyclist B starts from rest with an acceleration of 6 meters per second, while A is in pursuit of B with velocity of 20 meters per second and acceleration of that. So let's see how the simulation is. So now let's run our simulation and see what happens. I think you realize that at a certain point, cyclist A will overtake cyclist B. So he will overtake cyclist B at this point, and let's call that point C. So with that simulation, we can now come up with a sketch of what has happened. So this is a sketch which is summarizing the information that has been given and what has come up from the simulation. So this is cyclist B starts from this point, cyclist A starts from this point, and the distance apart is 36 meters. From here to here is 36 meters. Therefore, if cyclist B moves a distance x, if cyclist A moves a distance x, that means that from A to C is x meters, which is this. It implies that cyclist B will have moved a distance which is x minus 36, because from here to here is 36 and from here to here is x. Therefore this remaining part will be x minus 36. So that is why here we put s2 being equal to x minus 36. So these were the initial values. Initial acceleration was 6, initial velocity was 0 for cyclist B. For cyclist A, initial velocity was 20, initial acceleration was 4 meters per second. So now with that information, we can now answer the question. So we shall start with cyclist B, and cyclist B shall use the second equation of motion. So S is equal to U.T plus a half A.T squared. For cyclist B, S was x minus 36 and U was 0 and acceleration was 6. I think we remember it in this sketch we drew. So for cyclist B, S was x minus 36 and A was 6 and U was 0. So that's what we have substituted in this to come up with this part. So when we simplify, we shall come up with x being equal to 36 plus 3t squared. Now we shall call that equation 1, and then we shall go to cyclist A. So for cyclist A, we shall still use the second equation of motion, and when you realize from the sketch, the S is x, U is 20 and A is 4. So we shall substitute that in this equation to come up with x being equal to 20t plus a half times 4t squared. And when I simplify, I'll come up with x being equal to 20t plus 2t squared. So basically now I've got two equations and two unknowns. So the unknowns are x and t in both equations. So what we are going to do, we are going to solve these two equations simultaneously. I think we realize that all are equal to x, therefore when I equate the two equations, I'll come up with 36 plus 3t squared, which is this, being equal to 20t plus 2t squared, which is that. So I've equated the two. Next will now be simplifying. So when I collect like terms, I'll come up with t, a quadratic in terms of t, which will be t squared minus 20t plus 36 equal to 0. Now when I solve that using bulldozer method, I'll come up with t being equal to 18 seconds and 2 seconds. So remember in the question they asked for the 2 times when A overtakes B. So the first will be when t is equal to 6, it will be after 2 seconds, and another one will be after 18 seconds. So basically that's what they wanted, and now let's see how marks can be awarded. So this B1 will be for equation 1, and another B1 will be for equation 2. So the 2 marks so far. Now M1 will be for equating the two equations, and M1 is for you to solve the quadratic using either factorization or bulldozer, and A1 will be for output when both are correct. So t equal to 2 and t is equal to 8 has to be seen for you to get this A1. So basically that's how the 5 marks could be got. So now we shall go to question 2. So question 2 says an overloaded taxi traveling at, so question 2 was got from UNEB 1999 paper 2 question 4, and it says an overloaded taxi traveling at a constant speed of 90 kilometers per hour overtakes a stationary police car. 2 seconds later, the police car sets off in pursuit of the taxi, accelerating at a rate of 6 meters per second squared. Then they ask that how far does the traffic car travel before catching up with the taxi? So what we are going to do, we are going to first design a simulation for the information given in the question. So we have a road, and we have the position where the police car is, and also an overloaded taxi will be somewhere behind, so that in the question they said this overloaded taxi will first bypass the police car, and when the police car sees that the taxi is overloaded, will now drive after the overloaded taxi. So initially this is a police car, and behind there is a taxi. Now when the car starts running, when we run this simulation, we shall see, I think realize that what has happened is that initially the taxi overtakes the police car, then after that the police car sets over to run after the taxi, and up to a certain point where the police car will overtake the taxi again. So now at this point we shall now call it point B. So point B is the point where the police car now overtakes the taxi. And the question, I think we have realized that they have asked how far does the traffic car travel before catching up with the taxi. In other words, they want the distance from A to B, the distance from A where the taxi starts from, and up to B where the police car catches up with the taxi. So now with that information, we shall come up with a sketch diagram showing what has been given and also showing what has occurred in the simulation. I think we realize that in this case we have said that the distance traveled by the police car, let it be capital X. That means that your S, and I think we realize that both the taxi and the police car have moved the same distance from A to B. We realize from A to B, both the taxi and the police car travel the same distance. What does that mean? It means that here for the taxi, S will be X, and also for the police car, S will be X, as you see it here. Then for the taxi, acceleration was 0, but velocity was 90 kilometers per hour. Then for the police car, we are given that acceleration is 6 and velocity is initially 0. Now this t, if you have to realize on this simulation, it means that you realize that this car, the police car, starts after some time when the taxi has bypassed it. That means that, and in the question they told us that the 2 seconds later the police car sets off. So that means that after 2 seconds, when the taxi has bypassed the police car, that is when the police car starts and runs after the overloaded taxi until it meets. That means that the police car will have taken less time, 2 minutes, 2 seconds less, according to the question. The police car will have taken 2 seconds less than the taxi to move from A to B. So both cover the same distance, but the time taken will be different. That is why you have come here and say that if the taxi takes t seconds, it implies that the police car will take t minus 2. So note that the police car takes 2 seconds less. Most students fail to see that. So now that we have drawn a simulation and come up with a sketch. Now the next thing is to answer the questions that was asked. So we shall come here and say that for the taxi, we shall first convert the kilometers per hour to meters per second. Remember, 90 kilometers per hour, to change it to meters per second, you have to convert the kilometers to meters by multiplying by 1,000, and also change the per hour to per second by dividing by 3,600. Then from there we shall come and say that S1 is equal to U1 T1 plus half A1 T1 squared. So what we are doing, we are going to substitute for S1 is X, T1 is T, U1 is 90, which is now 25 meters per second, and A1 is 0. So let's do that. So when we do that, we shall come up with X being equal to 25t plus 0. Therefore, X equal to 25t is now our equation 1. So that is now for the taxi. What about for the police car? Police car, we shall still use the second equation of motion. S2 is equal to U2T2 plus a half A2T2 squared. So when we go back to the simulation, you shall remember that T2 is T minus 2, S2 is X, U2 is 0, and A2 is 6. So that's what we are going to substitute in our second equation to come up with X being equal to 0 plus a half times 6 times T minus 2 in brackets squared. Now when I simplify, I'll come up with that X equal to 3t squared minus 12t plus 12, and that will be now equation 2. So now we have 2 equations. So before we go to the next slide, let's see how marks can be awarded for this slide. So this slide, getting equation 1, that will be 1 mark, and also getting equation 2, that will be another mark. So now let's go to the next slide. Okay, so for the next slide, we are going to equate the 2 equations. So remember, we had equation 1, which is 25t, and equation 2 was 3t squared minus 12t plus 12. So when we equate the 2 equations, we are going to come up with 25t being equal to 3t squared minus 12t plus 12. So when I simplify, I'll come up with a quadratic equation in terms of t, which will be 3t squared minus 37t plus 12 equal to 0. And when I use bulldozer method to come up to find the values of t, the t will be equal to 12, or t will be equal to 1/3 seconds. But we shall say that t is cannot be equal to 1/3, therefore t is equal to 12. So why do we say that t cannot be equal to 1/3? It is because our 1, for example, when you look at this simulation here, you realize that t2 is equal to t minus 2. Therefore, when t is a third, t2 will be negative. So for that reason, we shall come and conclude that t cannot be equal to a third. Therefore, in the end, we shall come up with t being equal to 12 seconds. Okay, so now we shall come and say that from equation 1, remember that equation 1, this was equation 1, x equal to 25t, what will happen? From equation 1, we shall be able to get our x, which is 300 meters. So basically, that's what they wanted in the question, because they asked how far does the traffic car travel before catching up with a taxi. So the traffic car travels at distance x, and x was given, and x is 300 meters. So basically, that's how the question was supposed to be answered. Now let's see how the remaining marks could be got. So M1 for equating the two equations, and B1 for both values of t correct, and A1 is for you to get the distance which was required. Okay, so now we shall go to question 3, and question 3 says a lorry starts from a point A and moves along a straight horizontal road with a constant acceleration of 2 meters per second squared. At the same time, a car moving with a speed of 20 meters per second and constant acceleration of 30 meters per second squared is 400 meters behind the point A and moving in the same direction as the lorry. Then they ask that find part A, how far from A the car overtakes the lorry, and that is 10 marks. Then part B, the speed of the lorry when it is being overtaken. Okay, so what we are going to do, we are going to first design a simulation for the information given in the question. Okay, so those are the 2 points, and 1 point will be for the car, another point will be for the lorry. Okay, just as the information was given, they say that the car is 400 meters behind the lorry. So this is point A where the lorry is, and this is point B where the car is, and this car is 400 meters. So the distance from B to A is 400 meters. Okay, so they want how far from A the car overtakes the lorry. Now when we run our simulation, we shall realize that this car, at a certain point, the car will overtake the lorry, as you can see. So let that point be point C. Okay, so in the question, what they want the distance from point A to the point where the car overtakes the lorry. In other words, they want the distance from A to C. Now with that simulation and the information given in the question, we can now design our sketch of the information given as shown. Okay, so now in this information, you realize that x is what they want, and that is s2, the distance moved by the lorry. Therefore, the distance moved by the car will be 400 meters more, because remember, from here to here it was 400, and from here to here we have said let it be x. Therefore, the distance moved from A up to point C will be 4x minus x plus 400. So that is where x plus 400 is coming from. Now this 2 was given in the question. Acceleration for the lorry was 2 meters per second squared, and initial velocity was 0. When you come to the car, initial velocity was 20 meters per second and acceleration was 30 meters per second squared. So basically that's the sketch of what has been given in the question. Now let's see how we can use this information to come up with the solution. So we are going to start with the lorry, and for the lorry we're going to use the second equation of motion. So we have to substitute for S1, U1, A.T, A1 and T. Okay, so when you go back to this simulation we designed, you realize that okay, so this was supposed to be S1. This is S1, not S2. So this was supposed to be S1. So S1 is X, and U1, A1 is 2, and U1 is 0. So let's use that information. When you substitute that information here, this is what we are going to come up with. And when you simplify, we shall come up with X being equal to T squared, and that is equation 1. Then we shall go to the car. For the car, we shall still use the second equation of motion. So you have to substitute for S2, U2, T, A2, and T. So when you go back to our simulation, you realize that S2 is X plus 40, U2 is 20, and A2 is 30. So let's substitute that in this equation 2. So when you substitute, we are going to come up with X plus 400 being equal to 20T plus a half times 30T squared. And when I simplify, I'll come up with X plus 400 being equal to 20T plus 15T squared, and that is equation 2. So before we go to the next slide, let's see how the marks for this slide could be awarded. So B1 will be for substitution in the second equation for the lorry, and B1 another B1 for the equation 1. Then here for the curve, B1 will be for substitution in the second equation, and B1 for the output for the equation 2. So what we are going to do, we are going to substitute equation 1 into equation 2. Now equation 1 was X equal to T squared, and equation 2 was X plus 400 equal to 20T plus 15T squared. So what we are going to do, where there is X in equation 2, we are going to replace it with T squared. So this is what we are going to come up with. So you come up with T squared plus 400 being equal to 20T plus 15T squared. And when we simplify, we shall come up with a quadratic in terms of T, which is 14T squared plus 20T minus 400 equal to 0. Now when I solve the equation using bulldozer, I'll come up with T being equal to 4.6785 or T equal to negative 6.1070. But we know that T cannot be negative in this case, so therefore T will be equal to 4.6785 seconds. Now that I've got to equation with the value of T, I can go back to equation 1. Remember, equation 1 was given by X equal to T squared. So I'll go back to equation 1 and substitute for T to get the value of X, and the value of X will be 21.8884 meters. Now that we shall now conclude that the car overtakes the lorry at a point 21.8884 meters from A. So that was part A. Now we shall go to part B. So part A was saying how far from A the car overtakes the lorry, and that is 10 marks. We have got that. Now we are going to part B, where they say find the speed of the lorry when it is being overtaken. So the speed of the lorry should be V1 is equal to, we shall use the first equation of motion, so V equal to U plus AT. Now U1 is 0 initially, then A is 2, and T is what we have got as 4.6785. So when I substitute for all, I'll come up with my velocity at the point of when it is being overtaken as 9.357 meters per second. So basically that is what they wanted in this question, and now let's see how the remaining marks can be awarded. Okay, so here M1 will be for equating the two equations, and another M1 for solving the quadratic, and M1 still for both values. Then a B1 is for eliminating the negative value for you to conclude that T is equal to that. Then here m1 is for you to substitute in equation 1, and a1 is for you to get the distance or at point of overtake. Then m1 here for part B is to substitute in the first equation, and a1 is for the output with the correct units. So basically that's how the 12 questions in this 12 marks in this question could be got. Okay, so that brings us to the end of this lesson. Thank you for watching, and be reminded that the next video will be on velocity time graphs for linear motion. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the video has been uploaded for velocity time graphs for linear motion. Otherwise, thank you for watching, and also if you know of any student who is not yet in this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.